from electricity, okay, where we will use the few concepts to solve the question, where an electric current of 5 ampere is divided into three branches forming a parallel combination. Okay, so first of all you need to understand that there is an electric circuit, okay, and there are three parallel combination, three branches are there, okay. These are the parallel connections, right? And it's given that electric current of 5 ampere is divided into these three branches forming a parallel combination. So that means a current of 5 ampere is applied, right, into these parallel connected branches, right? And it's given that the lengths of the wire in the three branches are into the ratio 2 is to 3 is to 4, right? So here the lengths of the wire are, if this is L1, this is L2, and this is L3, right? So the length of the wire is given to you into the ratio. That means if this current is going through the circuit, then definitely there is a source of, there is a EMF source, there is a voltage source, right? Let's say this is V, right? And it's given that the length of the wire through this, all the three parallel connected branches L1, L2, L3 are given into the ratio of 2 is to 3 is to 4, right? We know that resistance of any wire is directly proportional to its length. So the ratio of their corresponding length is given to you for this all these three branches, right? Now, and their diameters, that means D1 is to D2 is to D3. This ratio is also given to you, and that is 3 is to 4 is to 5, right? So this is given to you. So this is nothing but, this is length, right? And this is nothing but, this is diameter, right? Now these ratios are given to you. We know that resistance of any circuit or any wire is given by the relation rho L by A, right? Where rho is the resistivity, L is the length, and A is the area of cross section, right? So this A can be written as rho into L. This A is pi r square, right? So pi into r square. R is nothing but d by 2, isn't it? So we can write this resistance. This resistance is related as rho by pi, multiplied by L into 4 by d square. So here you can see rho and pi is, rho by pi is constant, okay, because rho is the resistivity of the material and pi is 3.14 or 22 by 7, right? So resistance is directly proportional to 4 into L by d square, right? This is your relation of the length of the wire for varying the value of resistance. So here if L1 length is used, the resistance will be L1 into 4 by d1 square. If L2 is used, L2 into 4 by d2 square. If L3 is used, then L3 into 4 by D3 square, right? So R1 is to R2 is to R3, which is given as which can be given as what? That is L1 into 4 by D1 square, L2 into 4 by D2 square, and L3 into 4 by here D2 square and here D3 square, right? Basically what we have taken all the three resistances. Okay, so these will be the ratio, right? Now coming directly to the question now. Here L and D, the ratio of L and D is given to you. Okay, so just the ratio of R1 and R2 and R3 is given. So here we can write we just find out the value of R1. So R1 is nothing but L1 into 4 by D1 square, right? I left the constant terms, right? So this will be 2 into 4 by, because these wires are made of same material, so this resistivity will be same for all the item, all the three branches, right? So 2 into 4, because length L1 L2 L3 ratio is given 2 is to 3 is to 4, so this will be 2 into 4 by D1 square. D1 square is nothing but 3 square, which is 8 by 9, right? Now R2 is L2 into 4 by D2 square, which is coming as L2 is here 3 into 4 by this 4. You can see 4 is the diameter for D2, so this will be 4 square. So this is 4 and 4 will be cancelled out, so this will be coming as 3 by 4, right? And R3 is calculated as L3 into 4 by D3 square, which is coming as what? R3 is, the length is L3 is 4 here, so just put in place of L3 this 4 into 4 by D3. D3 is nothing but this 5 here. These are the corresponding length and diameters for R3, so which I am putting over here. In place of L3 I put 4, in place of D3 I will put this 5, so this will be 5 square. So this is coming at 16 by 25, right? So students, you can see the parallel combination, into the parallel combination the three lengths of resistance is calculated: 8 by 9, 3 by 4, 16 by 25, right? So the circuit will be connected like this. Here 8 by 9, then this 3 by 4, and then 16 by 25. All these three resistances will be forming due to the three lengths of wire which are connected in parallel, and there will be a current of 5 ampere and there is a voltage source, right? Now here you can see R1, R2, R3 are connected in parallel, right? So what will be the equivalent resistance? R equivalent will be calculated as 1 by R1 plus 1 by R2 plus 1 by R3, where this is R1, this is R2 and this is R3, which is calculated. Now this will be giving you 1 by R equivalent equal to 1 by R1. This will be coming as 1 by 8 by 9, which is 9 by 8 plus 4 by 3. Just denominator will go to the numerator, plus 25 by 16. So this will be giving you 8 and 16. The LCM will be 16. 16 into 3, 48. So 48 will be the LCM, and into the numerator we have 8 into 6, 6, 9, 54 plus 3, 16, 16, 4, 64, 16, 3, 3 into 25, 75. So when you add these three, you get 60, 50, 110, 110 plus 7, 180, 180 plus 8, 188, 188 plus 5, 193. So 193 by 48 is the value of 1 by R equivalent. So basically R equivalent is nothing but 48 by 193, right? So I am drawing it over here. So the parallel combination of three parallel connected resistances will be that circuit will be simplified as this, right? Here the value of R equivalent is calculated, that is 48 by 193, right? So this much ohm is the resistance of this equivalent resistance due to these three parallel connected circuits, right? Now from here let us start. Now we will calculate the voltage of this. If the equivalent resistance for the three parallel combination of resistances are calculated, then the voltage will be, just apply the Ohm's law, V will be equal to I into R. We are knowing the value of I, that is 5 ampere of current is flowing through that three parallel connected circuit. So the equivalent resistance is this. So 5, put up the value of 5 in place of I, and R equivalent is 48 by 193. So this will be giving you 5 8 40, carry 4, 5 per 20 plus 4, 24. So 240 by 193 volt is the value of this voltage source. So this V is calculated as 240 divided by 193 volt, right? Now since V is calculated, we need to find the current in each branch, right? So the current in each branch, that means if these were the resistances, I am just splitting the circuit again to its previous form, right? Then we can write this voltage. The voltage is calculated to you. What is the value of this voltage? We already calculated 240 by 193, right? So 240 by 193. Now this is the voltage. Now R1 we have already calculated, that is nothing but 8 by 9 ohm into this section of wire, and here R2 is nothing but 3 by 4 ohm, and R3 is nothing but 16 by 25 ohm. So here we have three resistances and current of 5 ampere. Now it has been asked that what is the value of I1, what is the value of I2, and what is the value of I3, because if these are the three currents which are flowing through the three branches, and this 5 ampere is split into these three branches, and it has been asked that find the current in each branch if the wires are of the same material, right? So here just apply the voltage across this length L1, across this length L2, and across this length will always be the same, because you can see this is a parallel connected circuit and voltage is always equal to 240 by 193 for all these three branches. So voltage equal to 240 by 193 will be equal to, just apply the KVL, Kirchhoff's voltage law. So that is I1 into R1. So here we can see, just put up the value of R1. R1 is nothing but 8 by 9, right? So this will give you the value of I1 as 9 into 240 divided by 8 into 193 ampere. So this will be the current I1. This will be the current I1 as flowing through the first branch, right? And this will be 8 into 3, 24, 30. So 270 by 193 ampere. You can just solve it. Its value will be coming around 1.5 or 1.4, right? This current will be flowing through the first branch, right? Now since this is parallel connected, again the voltage of 240 by 193 will be applying to the second length only, second length also, L2. So that will be equal to I2 into R2. What is the value of R2? R2 is 3 by 4. So just put off 3 by 4. So this will give you the value of I2. This will give you the value of I2 as 4 into 240 by 3 into 193. So this will 3 8 24 80. So this will be 240 by 193 ampere. This is the value of I2, this one, right? Now I3 is left, this one, because into the third branch I3 was flowing. Now the against the same voltage, because all these three branches will be having the same voltage which is parallel connected. So V equal to 240 by 193 will be equal to, just apply again the KVL, K3, I3 into R3. What is the value of R3? 16 by 25. 16 by 25. So this will give you the value of I3 as 240 multiplied with this 25 divided by 193 into 16. So this will give you 16 16 80 16 5. 15 into 25 by 193. 15 into 20, 25 into 15. So that is 375 by 193 ampere will be the current of I3, that is into the third branch. So we have calculated I2, we have calculated I1. So we can say that the three currents as flowing through these three branches into the first branch, it will be I1, that is 270 by 193 ampere. Into the second branch, it will be coming as I2, 240 by 193. So it's 240 by 193 ampere, right? And into the third branch, here you can see I3, I1, I2, I3. I am writing these values only. So I3 is coming at 375 by 193 ampere. This is our answer. So students, in this way we have find all the three currents which will be flowing through all these three lengths of wire, which is whose relation resistance is calculated using the relation R equal to rho L by A. Here we have been given with the length ratio of the length of the three wires and the ratio of the diameter of the three wires, and we use the formula to solve it, right? Thank you so much for watching, students. Take care. Happy learning. Bye bye. See you again. Take care.